So hello and welcome back to problem 3.8. Now let's take a look at what this exercise is about. In problem 3.8, we consider a so-called deferred temporary life annuity due, where the payment stream looks like this. And then he says the present value looks like this. So this is kind of not really a surprise because the only thing that happens here is we take each of the payments at each of the times t equals 0, 1, 2, and so on, and we discount it all back to time 0. So then he says, explain this product in words and argue why a pension saver may be interested in such a product in practice. So that's the first thing that we are asked to do here. So that's the first thing we're asked to do. And then we're asked to calculate the expected value of the present value. So this is what we call the expected present value at time 0. In general terms of TPX, and show that the expected present value is given by this expression. Now some of you have actually asked me, well, the expected present value, is that the same as v of 0? And the thing is, it's almost the same as v of 0, because v of 0 is the expected present value of strictly only the future payments, whereas here we're looking at the expected present value of all of the payments of the future, including the payment at time 0. So this means that if you want kind of a symbol to denote this, then it's v at time right before 0, which is what the minus stands for. So let's try to understand the payment stream here, b of t. So the benefit payments are given as the indicator function of the time t being smaller than time of death, and the time t being in the interval between k and k plus n, right? And then the next part here, where they split a product of indicators, where they split the indicator of the intersection of two events into a product of indicators, well, that is if I have two events. So if I have two events where I have their intersection, then this is equal to the indicator of one event multiplied by the indicator of the other event, because this one over here is 1 if and only if I have an element in A and an element in B. And over here, this is 1 if and only if I have an element in A and an element in B. So this is why these two indicators are equal. And that is why we can split this up into the product of two indicators as such. Okay, so how should we explain this product in words? A good idea is to start with a timeline and then kind of draw up which parts of the timeline are interesting. So let's try to look at the timeline here. We have that there is only a payout at times between k and k plus n, so that's pretty interesting. So we must have k and k plus n on this timeline, and also there's only a payout if there is survival past time t. So that means that if we are standing at if we're looking at someone who dies at time something before k, so if we assume that time of death tx occurs before k, then that means there is no payout. However, if we have someone dying at time k plus something before k plus n, then that means there is payout in the years k, k plus 1, k plus 2, and so on and so on. So then there is payout until time of death. Payout until time of death. And in the last case, if we were so lucky that death occurs after the contract expires, then there is payout from time k all the way to k plus n minus 1, because we have to remember that if we stand in time k plus n, then there is no payment because of this strict inequality. Yes, so the maxed out positive scenario is the case where there is payout in times, one time at k plus 1, and then k plus 2, and so on up until k plus n minus 1. So there are kind of these three different scenarios that we may consider. So how does this product work then? Well, then we can actually see that this product pays out 1. So this product starts payout k years from now. And pays 1 each year as long as the insured is alive. And the last payment falls either at time k plus n minus 1 if the insured dies after expiry. So if tx is greater than n plus k, or the last payment falls at the time the last beginning of year right before death. So it falls at the beginning of the year of death. So in short, it means k years with no payout, and then payout each year until death or until expiry. And this is what we call in Danish ratepension. Often ratepension will allow you to receive payout for n equal 10 or 15 years, and then no more payout afterwards. So what is the reason that somebody would be interested in such a contract where we only receive payout for a limited number of years and not until death? Well, the thing is, if you compare two contracts, one where you have a temporary payout period, so where it expires at n, and one that lasts your whole life, which we in Danish also call a livrente, then how do these two compare? Well, the thing is, in this thing, the insurance company risks eventually paying out in more years than in this case, because the number of years with payout might exceed n. And in such a case, this product will be more expensive to buy, and also the payout might be less compared to this product if you pay in the same amount of money for the same amount of years. So it kind of depends on how optimistic you are about the remainder of your lifetime, right? So if you expect to live very, very long, then probably you should get at least a proportion of your savings as a lifelong annuity. And if you're quite sure you won't last that long anyways, then you can just buy a temporary annuity. Normally what people do is they actually buy a combination, so that you will have the temporary annuity for a number of years and uphold a certain standard of living, and then after that live off of the lifelong annuity. So that's also a way to do it. Another reason why some people buy this or this, it can also have something to do with taxes. tax rules are different for different products, but that is something that you will learn in the law part of insurance and law. So I will not talk more about that. So that was part A. In the next part, we will calculate the expected present value, and that will also be the fun part. So see you guys in the next part.